Good afternoon, students. Let me start my session. Okay, so hope you all heard about your external exams, right? Only one exam is left out for you, and that exam they want to conduct. And along with that, you have got some labs also, it seems. Okay, so you have to prepare well for those exams. Okay, so for that reason, what they are asking us is like we need to revise the portions from the next week. So again, you'll get the break for your second semester, and you have to proceed with your first semester for one more week. And one more week is for your preparation holidays, and then after that, one more week is for exams. Okay, total 3 weeks break you'll get. So don't forget anything related to your second semester subjects, because whatever they have postponed long back, that only they are conducting. So definitely they'll conduct your second semester exams. Okay, so make sure that you all like keep a track of your second semester subjects as well. Okay, don't forget anything related to that. Okay, and what is my problem now? Today and tomorrow I've got classes. Okay, and I came to the end of the module. Okay, so I thought to start the next module, and now I don't know. Like anyway, what I planned was I will just start with the next module as well, and I'll give you the basics related to that. And when your second semester regular classes starts, that time I will. I'll see. I'll just revise in one class the complete thing, whatever related to the the next module, whichever we are going to do. I'll just brush up everything, and I will like I'll continue with the further things. Okay. So in the last class, coming to the subject. So in the last class, we have started with the different voltage regulators. Okay, so what happens here? The voltage regulator, as you know, it will maintain constant output voltage. Okay, across the output terminals, it has to get the constant output voltage. In the sense, like if my Zener diode has the capability of operating in the breakdown region with 5 volts as the breakdown voltage, then I will get the output as 5 volts. Okay, like that how the voltage regulators will work. So whenever you're converting AC to DC, okay, then you need to have three-step process. The first thing is you need to rectify the signal so that you will get the pulsated DC signal. Then you give it to the filter. Still it will be the output of the filter will be still the pulsating DC only, but it is better when compared with your rectified output without filter. Then this rectified output with filter, whatever output you are getting, it is not still the DC signal, it is the pulsating DC only, where it is varying between two voltages, V maximum and V minimum voltages. Okay, so now what we are doing, we are giving it to the voltage regulator. So whenever input is varying, it means that the input, see this is what the voltage regulator what will do. This input here is nothing but the varying signal. This is how the signal input is here. Okay, so the input is varying. Okay, whenever the input is varying, we call it as line regulation. Line regulation. Okay, so input is varying, but still you have to get the constant output voltage. So this can be achieved by using the voltage regulator. So that is how it is providing the constant output voltage. Even though input voltage is varying, still it is able to provide you the constant output voltage. This is said to be the line regulation, and it will be achieved by using the voltage regulators. Okay, so this is what this is how the voltage regulators will work. And one more thing is whatever, if input is varying, we call it as line regulation. If input is kept constant and the load is varying, in the sense load resistance is varying, if the load resistance is varying, then it is said to be the load regulation. Load regulation, what does it mean? Load regulation in the sense, even though the resistance or the load resistance value is varying, still we are able to get the constant output voltage. Okay, so that is said to be the load regulation. Okay, so these are the new terms which I have introduced now: load regulation and line regulation and load regulation. Line regulation in the sense, irrespective of your voltage change at the input, the output will be still kept constant. That is what your line regulation. If the load resistance value is changing and still you are able to maintain the output voltage constant, it is said to be the load regulation. Okay, so these are the two things which I have introduced today. And then coming to the voltage regulator. So we have three different types of voltage regulators. Fixed regulator, it will provide you the either plus positive voltage or the negative voltage. Okay, positive voltage is the IC. There are different manufacturers. One person may give LM as the company name, or MC, like that. You have different companies which will start their name with the different alphabets. So positive voltage, it is like 78XX. This 78 indicates it is nothing but the positive voltage regulators. Negative voltage regulators, it will start, the number of the IC will start from 79. Okay, this 79 indicates it is providing the negative voltages. So how much voltage it is providing, that will be given by XX. Okay, so this XX, if XX value is 0.5, then it indicates 5 volts. 10 or 10 volts, like that. So this last two digits, no, it will tell you how much output regulated voltage you are getting. Okay, how much DC output voltage it is providing, that will be given by this XX value. And as I've mentioned, 79 indicates negative voltages, 78 indicates positive voltages. Next, adjustable voltages. Adjustable voltages in the sense, it is again the IC only. What happens here is, the output voltage will be regulated, and it can be adjustable. Adjustable in the sense, now a particular voltage regulator, whichever I have, if it says that it will be able to provide you the output voltage from 5 volts to 10 volts, it means that you can set any voltage from 5 volts to 10 volts. In between anything, whatever value you want to set, you can set. You can just set the output voltage to that particular voltage. So this is said to be the adjustable voltage regulators. Then switching voltage regulators are nothing but, here it will take the input as a DC and it will provide output as DC. So in between, what it will do, it will convert the DC signal to the high frequency signals, and then it will give you the DC signal from that AC signal that is provided. Okay, so those are switching voltage regulators. Okay, and okay, so now specifically, we have to study LM78XX, and I'll provide you some details related to 7805. So 7805. This 78 indicates it is nothing but the positive voltages, positive voltage regulator, which is nothing but the fixed voltage regulator, and this 05 indicates it is providing you the 5 volts. Okay, so here I have taken one particular voltage regulator, which is LM78XX. Okay, so let me just draw the block diagram of this LM78XX, LM78XX, and I'll just explain you the basic principle on how it is able to provide you the constant output voltage. So here I'll have the pass transistor. So this is input. Here I will be giving you the input, and LM78XX, it is a 3-terminal device. 3-terminal device. 3-terminal device, which will be in this way. Let me just draw the LM78XX first. So LM78, then I'll give you the block diagram representation. So this is V input. This is the first pin, second pin, third pin. Okay, so and this is grounded. Okay, 3 should be grounded, and in between 1 and 3 you need to provide input voltage, V input voltage. Okay, V in you need to provide between pin number 1 and pin number 3, and you need to take output between pin number 2 and the ground pin. Between these two you need to take the output. Okay, so it is a 3-terminal device. Okay, so this LM78XX voltage regulators are 3-pin device. Okay, so where input will be given between two terminals, and output will be given taken between two terminals, where one terminal is acting as common between the input and the output. Okay, so this is how the LM78X6 will be. And then coming to the block diagram of, I will draw it little small, up small, block diagram of LM78X6. So what it will have, here I'll be giving input and here I'll be taking output, V out. Okay, so what it will have is, it will have the control circuit. In between it will have the control circuit, and this control circuit consists of pass transistor, okay. Then to this pass transistor you will have an additional device connected, which is nothing but the thermal shutdown and current limiting circuit. Okay, so this entire thing is nothing but the control circuit. Okay, control circuit. In the control circuit, you will have the pass transistor and the thermal shutdown and current limiting circuit. What are this? I'll tell you. Okay, first let me draw the diagram. And here, what you'll have voltage divider circuit, which will divide this V output voltage between the resistors R1 dash and R2 dash, R1 dash and R2 dash. This is the common ground terminal. Okay, and here whatever I have, this in between R1 dash and R2 dash, I'll take one point and I'll connect it to the op amp, about which we will be studying in the next module. Okay, op amp. This is nothing but the op amp, which will have the inverting terminal and the non-inverting terminal. Okay, the output of this op amp. This is the op amp which is working as a comparator. This is nothing but the op amp, which is nothing but the comparator. So this is the op amp which is working as a comparator, and to this one voltage will be nothing but the V reference voltage. Okay, so this is the internally generated reference voltage. Okay, so I can I may be able to use the Zener diode. Zener diode can be used to provide this V reference. Okay, so let me consider this V reference is some more 1 volt. So I need to select the Zener diode, which is used as voltage regulator, which will provide whose breakdown voltage is near to this 1 volt, and I'll be able to connect here so that it will provide me 1 volt. I'm just telling as an example. Okay, so what this comparator, this is a comparator. Okay, so what this is a overall diagram of your LM78X6. Okay, so this is just the block diagram representation. So here what happens is, this is nothing but the comparator. So the function of the comparator is, what it will do, it will compare both the inputs. This is one input and this is the other input. Okay, so this is one input and this is the other input. Okay, so what happens here, the comparator, what it will do, it will compare these two voltages. So when you study op amps, it will become more clear, but let me just give you the very basic idea here. Okay, so what the comparator will do, it will compare these two voltages, which is given to this plus, whatever plus is there, generally we call it as non-inverting terminal, and minus whatever you have, we call it as inverting terminal. The reason why we call this as non-inverting terminal and this is called as inverting terminal is, see, whenever you give, see, op amp is nothing but the op amp. From the name, it indicates that it is the operational amplifier. Operational amplifier. So what this op amp will do, it will amplify the signal, input signal. Okay, so this op amp is also said to be the operational amplifier because it will amplify the signal, and along with that it will perform some mathematical operations like addition, subtraction, integration, differentiation. All this mathematical operations can be performed using this op amp. That is the reason it is named as operational amplifier. It is also said to be the difference amplifier. Okay, why it is called as difference amplifier? In the sense, it will take the difference between these two inputs and it will amplify the signal. So that is the reason it will it is said to be the differential amplifier. But right now what you understand is this is the op amp. So whenever it is amplifying, if I provide input to this non-inverting terminal, plus is said to be non-inverting terminal. If I provide input to this by making the other terminal in the sense inverting terminal ground, whatever output I'll be getting here, it will be in phase. In the sense, let me just I'm just introducing the op amp. So let me consider I have the signal like this, okay, with some 0.5 volts. 0.5 volts peak to peak. If I have a signal here, what it will do, it will amplify that signal to some higher voltages like 5 volts or whatever it might be, but it will be in phase. See here, if you observe this signal and this signal, it will be in phase. Okay, so in phase in the sense, like only the signal will be amplified, but it will its phase value will be same. Okay, so whatever phase you have here, the same phase will be here, like that. This phase will not change. So that is the reason it is said to be non-inverting terminal. Now the other way, negative sign, you have the inverting terminal. This is my inverting terminal. This is called as inverting terminal. If I ground this and if I provide input voltage here, let me consider I'm providing this input voltage. So what will happen to the output here is it will be inverted. It will be amplified. Okay, if I give 0.5 volts here, it will be 5 volts only. 5 volts or 10 volts based on the amplification factor. But what will happen is here these two are out of phase. 180 degrees out of phase. It means that see, if you compare here, okay, so the angle at this point and the angle at this point will be different. In this sense, it will be tilted by 180 degrees. 180 degrees. Okay, so it is inverted signal. So since it is inverted signal, we will call this terminal as inverting terminal. Okay, so I've just given you what is op amp. Anyway, in the next module, we'll study everything related to that, applications, how here here I'm saying that it is operational amplifier, right? How it is performing the addition, subtraction, integration, differentiation, everything we'll study in the next module. Okay, so here coming to this one, what we are doing, I've just told you what is this inverting and non-inverting terminal, for which I have given you all this introduction. Okay, so fine. Now what this op amp is made to work as comparator. Okay, the function of the comparator is it will compare both the input voltages. So whatever is connected to the inverting terminal and whatever is connected to the non-inverting terminal. This is V reference. This V reference is generated based on this V out. Okay, based on the V out value, this V reference will be based on V out value, based on R1 dash and R2 dash. It means that let me consider that I'm giving some input voltage and I need to get some 5 volts or some output voltage 5 volts. So based on this 5 volts, this V reference will be generated by using R1 dash and R2 dash. Okay, so that is how the V reference is generated. And here what happens here is the comparator. This V reference voltage will be compared with the voltage which is coming from this point. Okay, so this is the inverting terminal voltage. Okay, so both the inverting terminal voltage and the non-inverting terminal voltage will be compared, and it will provide you the error signal. Okay, error signal. So that is the reason this part of the circuit is also said to be error detecting circuit. Error detecting circuit. So what it will do, it will compare both the voltages at this point and at this point, in the sense inverting terminal voltage and the non-inverting terminal voltage will be compared, and it will provide you the error signal. Okay, so if everything is proper, this error signal will be given to the pass transistor. I will explain you this in some time. What this terminal shutdown and current limiting circuit will do if everything is proper. What is that everything? I'll explain you once again. So if everything is proper, the signal, whatever error signal it is getting, it will be given to the pass transistor, and this pass transistor will have some control element. What it will do, based on the feedback signal, this entire thing, whatever I'm applying, it is nothing but the feedback signal. See, output, part of the output is fed as an input to the this transistor. So what is happening, it is getting some feedback, and this feedback will help the pass transistor to stabilize the output voltage. So maybe I may get some error. Let me consider, instead of getting 5 volts, I'm getting 4.9 volts only. So this 4.9 volts, this comparator will say that the voltage, whatever is obtained at the output, it is not 4.9, it is less than that. So that signal will be given to the pass transistor. This pass transistor, what will do, it will adjust the output value accordingly, so that my output will be just 5 volts. Okay, so that is what the use of the pass transistor here. Now coming to the thermal shutdown and current limiting circuit. So what happens here is thermal shutdown. Okay, so if the device is overheated, okay, if the temperature of the device is very much greater than 175 degrees Celsius, something like that. So what this thermal shutdown will do, it will stop the it will automatically shut down the complete system. Okay, it will automatically shut down the complete system, and it will not provide any error signal to the pass transistor. And in the same circuit is also having the current limiting circuit. Current limiting part of the circuit will also be there. Okay, so what it will do is it will limit the current. Okay, it will limit the current, in the sense it will not allow more than 1 ampere of current. Okay, like that it will work as current limiting resistor as well, and it will also provide you the thermal shutdown, in the sense if the voltage is increasing, if more voltage is if the temperature of the device is above 175 degrees, then what it will do, it will automatically shut down the system. Okay, so this is a complete operation of this LM78XX. Okay, hope it's clear to you.
Yes, ma'am.
Okay, so here I have spoke something related to V reference and the voltage here. So if you want to find out what should be the V reference here, I have told you that internally it will be calculated based on this V output value. Okay, so how it will calculate is, and one more parameter here, what you need to consider in the op amp is, op amp terminals will not draw any current. Keep this in mind. I will explain you in the next chapter. Op amp terminals will not draw any current. The reason for not drawing any current is for any amplifier, if it has to amplify the signal properly, the input impedance should be very high. Input impedance or the resistance, whatever you call input impedance, should be very high. Okay, ideally it should be infinite. Input impedance should be infinite, and the output impedance should be very low. So Z0 is called as the output impedance. Z0 should be very low. Ideally it should be equal to 0. Okay, so since the input impedance of the op amp should be very high, ideally the current through this terminal and the current through this terminal will not be same. Okay, so this I'll explain you when I'll be teaching you the op amp ideal equivalent circuit of the op amp. Okay, so this terminals will not draw any current. Okay, so if this terminals are not drawing any current, then it means that R1 dash and R2 dash are in series. Okay, this current is not drawing any current. It means that whatever current is flowing through this, the same current will flow here also. So same current is flowing, they are considered to be in series. Okay, and here the input voltage to this R1 dash and R2 dash is nothing but V out. So if I want to find, see, I want to find what will be the voltage here. Okay, voltage here. This the voltage which is at the which is at the non-inverting terminal, I'll call as V plus, which is nothing but V reference value. Okay, and this voltage, whatever is connected here, let me name it as V dash. V dash. So I need to find this V dash voltage, V minus, V dash or V minus. Why it is V minus? Because it is given to the inverting terminal. So I'm naming it as V dash. Okay, so I need to find this V dash. V dash is nothing but with respect to this ground terminal and this node, it is V dash. It means that the V dash is nothing but voltage across the resistor R2 dash. So I need to find voltage across this resistor R2 dash. So according to the voltage division rule which I have explained you before, the voltage in any resistor when they are series connected is given by input voltage. What is the input voltage? V out. V out is the input voltage. So V dash will be equal to V out into resistance there. What is the resistance there? R2 dash. R2 dash divided by total resistance R1 dash plus R2 dash. R1 dash plus R2 dash. This is nothing but the voltage here. V dash. V dash is nothing but voltage voltage at the inverting terminal. So I'll write. Let me write. V dash is nothing but V out into R1 dash divided by not R1 dash, R2 dash, because it is the resistance across the resistor R2 dash. Okay, so R2 dash divided by R2 dash plus R1 dash, total resistance. This is nothing but the voltage at the voltage at the inverting terminal. According to the virtual ground concept of your op amp, V plus should be equal to V minus. It means that the voltage at this node or at this inverting terminal should be equal to the voltage at the non-inverting terminal. Okay, so this is one more virtual ground concept which is very important. This also we'll see in the next module. Okay, so here V plus should be equal to V dash, and you know that V plus is nothing but V reference. So that should be equal to V out into R2 dash divided by R2 dash plus R1 dash. So I was saying that the reference voltage will be derived by using R2 dash and R1 dash. Okay, so by using V out into R2 dash by R2 dash plus R1 dash, this V reference voltage will be generated. Okay, so this is all related to the general block diagram explanation of LM78XX positive fixed voltage regulator. Okay, coming to the specifically 7805. So the output voltage here should be plus 5 volts. The output here should be plus 5 volts. Okay, so specifically if you want me to give some typical values of this 7805, it is the LM7805. It is a 3-terminal device. Input will be provided between these two terminals and output will be taken between these two terminals. V output will be taken between these two terminals, and this is grounded. Okay, this is 1, 2 and 3, third terminal. Okay, and coming to the output voltage that it will provide you 5 volts. Okay, 7, 8 indicates positive voltage regulators, and 0.5 indicates how much it is, how much regulated output it is giving. Okay, from the unregulated input. Unregulated in the sense it is not constant input, it is the varying input like this. Okay, some varying voltage, it's not the constant voltage. This is said to be the unregulated input, unregulated power supply. To this is the unregulated power supply. From the unregulated power supply, you'll get the regulated power supply. This is the regulated output. Okay, from unregulated power supply you get the regulated output. Okay, and this is providing you 5 volts. Okay, and as I was speaking about line regulation and the load regulation, line regulation in the sense how the output is changing. Generally will be calculating percentage line regulation. So percentage line regulation is given by change in output voltage by change in input voltage into 100 as it is in percentage. Okay, change in output voltage divided by change in input voltage will give you the line regulation. Line regulation in the sense here we are providing the unregulated power supply. So how much regulation it is providing, that is given by the line regulation. For the signal which is varying in the voltage when it is provided to the 7805, when unregulated signal is given, how we are getting the regulated signal. Okay, so what is that percentage? That we are calculating by using change in output voltage divided by change in input voltage. If you want to find the load regulation, generally regulation will calculate in terms of percentage only. Load regulation, then what you need to do, you need to take the formula as V no load minus V full load divided by V no load into 100. This is what the formula. So using this, what it means is if you have connected it to the load. Okay, so when there is no load, what is the regulation that you need? What is the output voltage that you need to find? Minus when there is a load, you need to find what is the output voltage. Okay, so by using V no load minus V full load divided by V full load into 100, it will provide you the how much load regulation it is providing. It means that for the change in our load resistance, how the regulation is changing. That is what is given by load regulation. Okay, so here specifically we don't have any typical values for this. We don't have to derive it specifically, but I'll just give you the values. That's it. Typical values I'll give you. Okay, so the load regulation for this 7805 is 10 millivolts. 10 millivolts is the load regulation. Okay, and for the line regulation, the typical values for your 7805, it is 3 millivolt. Okay, and this 3 millivolt and 10 millivolt is achieved when the input is changing from 7 volts to 25 volts. And here I want to specify one more important parameter. So whenever you are giving the input voltage, okay, to 7805, so how much voltage it will provide? It will provide you 5 volts. So always at least the input, whatever input you are providing, the input should be at least 2 volts greater than the output voltage. Okay, 2 to 3 volts. Generally 2 to 3 volts should be greater. In the sense here whatever voltage I am giving, no, this voltage should be greater than this regulated output. In the sense, if I have to provide 5 volts, the minimum voltage, the minimum input voltage should be 7 volts. Okay, 7 volts should be the minimum voltage. Okay, so when we are varying between 7 volts, this if you take 7805, when the input voltage is varied from 7 volts, so varying from 7 volts to 25 volts, the output will be equal to 5 volts. Okay, and here here the input is containing some ripple, right? This is nothing but the ripple. Okay, so ripple in the sense the AC amount, the amount of AC that is present in the pulsating DC is given by ripple. Okay, so that ripple rejection ratio in the sense how efficiently, how much ripple the 7805 is able to reject, that is given by 80 dB. 80 dB. dB is nothing but decibels. Okay, generally we calculate this ripple rejection ratio as by using the formula 20 log base 10 and ripple factor. Some ripple factor value. Okay, so 80 dB. I'm saying that it is 80 dB in the sense this ripple, whatever value I'm considering here, it is 10,000. 1000. See, it's nothing but 20 log 10,000. Okay, 20 log 10,000 base 10. Okay, so the rejection factor is this much. Okay, so it is given by 20 log 10 cube base 10. So it is nothing but 20, 1, 2, 3, 4, 10 power 4. So it's nothing but 80. 20 into 4, it is 80 dB. Okay, generally we calculate this ripple rejection ratio in terms of dB. Okay, and this is how we calculate. So it is having the rejection capability, very high rejection capability. It is able to reject the ripple, input ripple by the factor of 10,000. 10,000. That's what it means. Okay, fine. Now coming to the additional components which are required here is, I'll draw one more time. It's okay. So I have 7805, which is the voltage regulator. Here I am providing some input. V input is given. Okay, and this V input, as I was mentioning, it is coming from the unregulated power supply. Unregulated power supply in the sense the rectifier, then from the rectifier to the filter output. That filter output, whatever I am getting, I am giving it to 7805. Okay, so what happens here is, if I am not using any capacitor here, it will provide me the oscillations. Oscillations in the sense, it will provide you some sinusoidal signal with certain frequency. Okay, so that is the reason you need to connect one bypass capacitor here. So this bypass capacitor, let me name it as C1. Okay, so if I am using this bypass capacitor, it will eliminate this frequency of oscillations. Okay, sinusoidal signal with certain frequency, that will be avoided. Okay, because I need to get the unregulated power supply only to the 7805, and you may connect one more bypass capacitor at the output here. Okay, so the reason for connecting this is it will help to reach the output in a less time. Okay, so transient response, we generally call it as transient response. Okay, transient response in the sense the amount of time that it will take for the output to reach from the initial value to the final value. Final value here is nothing but 5 volts. So how fast the final value is obtained. Okay, so that time will be controlled by using this second bypass capacitor. So typically for this 7805, the typical value is 0.22 microfarad. Otherwise, generally we will vary it from 0.1 microfarad to 1 microfarad. Okay, so that is what your C1 and C2 values should be. Typically for your 7805, it is 0.22 microfarad for C1, and C2 is 0.1 microfarad. So these are the typical values, and always whatever input you are providing, you have to at least provide 2 to 3 volts greater than the output regulated voltage. Okay, so this is all related to your LM78XX and also 78, specifically 7805. So in the exam, they may ask you write short notes on LM78XX. In that case, what you need to do, you just start with the basic voltage regulators. So what are the different types of voltage regulators you have? So what is positive voltage regulator? What will be the IC number of your positive voltage regulator? And then the block diagram. Where is the block diagram? This block diagram, and explain each and every parameter, like this is acting as voltage divider circuit, this is acting as comparator, this is acting as the thermal shutdown, this is the pass transistor, what is the action of pass transistor, what is the action of this thermal shutdown, and current limiting circuit function, how it is working and all that. And then finally you provide this equation, V reference equation. V reference is nothing but V out into R2 dash divided by R2 dash plus R1 dash. Okay, so how you'll be getting this equation, that also you can explain. And finally, give the typical values of your 7805. Okay, so that's all with respect to this complete module. Okay, complete module is over. I know tomorrow I'm planning to start module 3. Module 3. I will leave module 2, then I'll start module 2 later. First I'll finish module 3 and then I'll go back to module 2. Okay, so hope this is clear to all of you. Anybody has got any doubts anywhere, please let me know.
No.
Others also please let me know if you have got any doubts.
No, ma'am, no doubts.
Okay. So tomorrow, shall I start the next module or shall I revise this module once? I'm really not
Ma'am, you
understanding
can
what it is.
start the next module.
Okay, okay, fine. I'll start the next module then. Okay, again, no, what happens if I delay now? What happens at the end? It will our exams, everything, second IA, third IA, everything will be nearby, and like we have to rush like anything. Okay, so let me just start the next module tomorrow, and that's it. Whatever introduction I've given you, it will definitely help you in the next module, because in the next module we'll study everything related to op amp only. Op amp. See, a little introduction I've given here only, like what is op amp, what is its function, what it is doing, everything, like very little explanation I've given here. So in the tomorrow's class we'll see in detail. Okay. That's all for now. If anybody has got any doubts or anything you want to discuss with me, you can. Otherwise, you can leave the class. Thank you.
Thank you.
Thank you.
Thank you, ma'am.
Thank you, ma'am.
Thank you.
Ma'am, you can start revision after this first semester examination.
Second module revision and first
Yes,
module
ma'am.
revision.
Yes, ma'am. After that examination, when we gonna end the first sem examination,
Hmm.
at that time you can start the revision
Hmm.
so
Hmm.
that we can refresh up with the modules
Hmm.
previously.
Okay, okay. See, if not immediately, at least one day I will spare for this. Okay.
Okay, ma'am.
One
Not an
day,
issue.
some Friday where I can extend the class, no? Because anyway, after my class, you people are free. So on that day, like whenever I get chance like that, then I will like I'll give you the glance of that complete module on that day.
Yes, ma'am. Okay.
Okay. Okay.
Okay. Thank you, ma'am.
Thank you, ma'am. Thank you.
And ma'am, you have any idea about offline classes and all?
Offline, they're not.
Means they
Uh,
are calling us before
See,
19.
so before 19th, it is now from Monday, whatever classes you have got, it is not offline classes. It is online classes only.
Okay, ma'am. That was
You
the
just
confusion.
check the heading. It is like online class timetable. Okay,
Okay,
so
ma'am.
it is online classes only, but to write your exams, you have to come back, because exams are not offline. Sorry, exams are not online, it is offline only. Okay, but anyway, you'll get the clear picture very soon. Okay, schedule, everything they'll fix, no? So you'll get all the details in a short span of time. Meanwhile, don't waste your time, prepare well. You have got enough time now, just for one subject and few labs. You've got so much of time, 3 weeks. Okay, at least 2 weeks, if not 3 weeks, at least 2 weeks you have got. So make sure that you utilize it properly. Okay, anyway, they are revising also. So since they are revising, like you can easily ask the questions, or like and moreover, I think you people have prepared for this exam, right?
No,
You
ma'am.
prepare.
Forgotten
No.
everything.
Okay, okay, okay. Okay, fine. But when they are refreshing, no, you may like you may recall everything. Okay. Let's hope for the best. That's it. From our end, what we can do, we will do that. Rest, we'll leave it to God. That's it.
Yes, ma'am.
Okay, ma'am. Okay. Any other doubts?
No, ma'am. No, no doubt.
Okay, okay, ma'am.
Thank you, ma'am.
Thank you.